So right away with this rational function, I can tell there's going to be a little bit of extra work. Take a look here. See the way those exponents look? This is top-heavy, higher factor of x on the top than the bottom. So we're in for a little bit of long division here. Let's do the normal stuff first. We're going to start off with the x-intercepts, right? Those are factors on the top of the fraction, which do not also appear on the bottom. There's no x minus 1 or x plus 3 on the bottom. So I get those x-intercepts pretty easy. It's going to be 1, 0, and negative 3, 0. Y-intercept, remember what we do there. We're just setting our x value equal to 0. So a lot of x's here, but should be pretty easy. Look, these are all going to be 0, 0, 0, 0, 0. All that's left is negative 9 over negative 6. So we're going to say 0, that's the x value, and negative 9 over negative 6. Now, all right, negative 9 over negative 6 isn't the nicest way to say this thing. We can simplify this fraction. So let's go ahead and do that. When you can, you should. So this is going to be 3 over 2 when we reduce the fraction. Vertical asymptotes, remember what those are. Those are factors in the denominator which are not also in the numerator. If you see a factor the same on the top and bottom, like exactly the same, that's a whole. It's not a vertical asymptote or an x-intercept. But these ones are going to be pretty straightforward. It's x equals negative 1, x equals positive 2. And now we get to the ends behavior. This one's kind of a pain in the neck because we have those, you know, the long division stuff to deal with. Okay, so to figure this out, I'm going to come down here and just bring some long division down here, and we'll suffer through this together. X cubed plus 5x squared plus 3x minus 9. That's numerator. Okay, denominator is 3x squared minus 3x minus 6. Now, if I go through the long division a little too fast for you, feel free to slow this video down, rewind, whatever you like, but try to follow the steps that I'm going to do. First thing, I'm dividing x cubed by 3x squared. Okay, the result that I get is 1/3 x. Now, what I'm going to do is multiply 1/3 x times this thing. Okay, I'm going to multiply those together. So I get x cubed. That part should not be much of a surprise. I'll keep it in blue ink. I get x cubed. Now 1/3 x times negative 3x is going to be negative x squared. And then 1/3 x times negative 6 is going to be negative 2x. Okay, so what I like to do at this point is put a parentheses around that whole thing to remind me that when I do this subtraction, I'm subtracting everything in the parentheses. Some other folks like to change the signs on each one of these things, like flip the signs right now and add them up. Well, that's fine. We can do that. Look what that would be. I just change all these signs, okay, to negative x cubed, positive x squared, positive 2x. And then I'm adding instead of subtracting. But whichever way you like it, I'm just going to go ahead and subtract. So the x cubeds cancel out. 5x squared minus negative x squared, that's going to be 6x squared. And 3x minus negative 2x, well, that's going to be 5x. Okay, so how many times, now look what I'm doing here, how many times does 6x squared get divided by 3x squared? Well, that's just 2. Okay, and you can multiply back down at this point, but I don't care about remainders, so this is my oblique asymptote. That is what I need to put in here. So I say y equals 1/3 x plus 2. That's my oblique asymptote. Now, remember why this is oblique. Got to make sure you don't do long division every time or you're just going to be hating life. It's only in cases where the x factor on top is bigger than the x factor on bottom. It's not often, but from time to time you'll see this. So let's go ahead and plot everything. Got all the hard parts done. I'm going to make the asymptotes in red. Okay, so I see there's a vertical asymptote at -1, a vertical asymptote at +2, and then there is this end behavior asymptote, the oblique asymptote, which has a y-intercept at 2, okay, and it has a slope that's 1/3. That's fairly shallow. Okay, so it's not a very steep curve. There's my asymptotes. Remember, this is the y-intercept right here. This is the slope. Okay, if you forget how to draw a straight line, you should probably review that. And now I'm going to draw the, let's get this ink a little thicker. I'm going to draw the asymptotes. So I've got an asymptote at 1, 0 right there, and another one at -3, 0. Let's see, where's that? I don't know, probably somewhere around here. And a y-intercept of 0, 3/2. So right around there. Now this would be easier if I had a grid. You'll have the grid when you do the homework problems on the computer, but in this case you just have to use your imagination a little bit. So I'm going to draw my best approximation of this function, and you can see some of these are going to be easy. Like, I know I have to connect these dots, but what on earth am I supposed to do with this? Like, do we just go like that? There's a problem there. Remember, you cannot cross a vertical asymptote. So we're going to have to go either up or down. Now, what's the problem with going down? Can you see what the problem is there? I just created an x-intercept where there should not be one. So our only other choice is to go up, like this. And over here, I'm going to go down. Now, how did I know? Here's another point. How did I know to cross right there instead of bouncing? Take a look at the factor which produced that x-intercept. This x-intercept right here comes from this factor. The exponent on that factor is 1, so that means cross, not bounce. As opposed to this x-intercept over here. Look at this guy. That's a 2. So that's going to be a bounce right there, that next x-intercept on the left. So let's deal with that one, because there's a little bit going on there. And I have to know, here's the next question. I know it's a bounce. Is it going to look like this? Or going to look something like that? Well, could be either. We have to use the asymptote for a clue. What asymptote is next to it? It's this one right here. Is that even or odd? That's an odd asymptote. See, it has an exponent of 1. So that means, whereas this side was up, the other side of it has to be down. Okay, that's what odd asymptotes look like. They alternate top and bottom. So that means I come up here, I hit that x-intercept, I know I'm going to bounce off of it, and now I just follow that oblique asymptote off to the left. You can make your curve look a little nicer. Now, on the other side of this function, right, all the way on the right side, remember, these are odd asymptotes. They're not even. So the behavior is going to be opposite. See, this is down. That means the other side of the asymptote has to be up, like this. And there's no reason I could cross that asymptote. There's nothing saying I can't. But there's no reason to. So we're just going to go like this. Okay, and there's my function.